picking up in lesson 2.5 where we left off. I would show you the first page of notes, but it got erased, so not by my doing, but by BenQ's doing. So I love BenQ. Okay, so we had looked on what, Wednesday? Yeah, by the way, no, quizzes aren't graded, so that's a weekend job. So that's a weekend job before anyone asks. So we had looked at example 1. We had talked about standard form. We had talked about zeros, and we talked about x-intercepts, right? Okay. Zeros being based on that highest power, all of your possible zeros. Okay. Now, officially, and this helps with a couple of homework questions. If your highest power is, say, x to the 5th, that means there are going to be a total of 5 zeros. Some of them real, some of them possibly imaginary. Now, when they ask about complex, okay, I know we think when we hear complex, we think a plus bi, we think only the imaginaries, but officially all zeros can fit into the complex category, because if a is present but b is 0, that makes it a real. If b is present, then that makes it imaginary. Okay, so when they ask you how many complex zeros there are based on looking at an equation or looking at the graph, complex is how many total zeros there would be based on the equation. Then if they ask you about just real or just imaginary, that is a separate number. And I can't remember which they asked you about. But I'm trying to give you a hint on something to do in homework. Okay? Complex zeros is the total number of zeros. Okay? So today we're going to write some equations. This right here is Algebra 2 review from last year about this time, because I just taught it in Algebra 2 yesterday. So, write a polynomial function of minimum degree. Okay, so they're not telling me what degree it's going to be. That's a difference from Algebra 2. Algebra 2 would say, oh, a 4th degree, so you know you have to have 4 roots. Here, they're stepping it up. Minimum degree, so whatever degree it is. In standard form, it means it needs multiplied out, with the real coefficients whose zeros include -3, 4, and 2 minus I. Okay, so as we start thinking about this, we have zeros of -3 and 4. We know how to put those into factors, right? 2 minus I we can do something similar with. What's the catch here? Do we remember the catch?
Do we have to do like f of x equals x plus 3?
We will.
And then like in a parenthesis, and then x minus 4 in parentheses, and then like it would be just 2 minus I and 1.
And we'll still have to put an x in with that 2 minus I. Okay, there's our catch. And what I was just getting ready to refer you guys to, at the top of your paper, we talked about this on Wednesday. I did put this screen at least in here so I can refer to it. Complex conjugate zero theorem. Okay, it had they used a different version name of it in Algebra 2, but it's the same idea. Okay, if a plus bi is a 0, then so is its conjugate. If they give you an imaginary 0, I've talked about this, imaginary zeros always occur in pairs. So if they give you 1, you have to also know, hey, I need the conjugate. Okay, so since, yep, we did this last year, since they gave me 2 minus I, then we also have to use 2 plus I. And that's because it is the conjugate. Okay? So, now, what degree is this going to end up being then? Degree 4, because I have 4 zeros listed. Okay? So, from here, okay, let's set this up. I am going to start it as f of x equals, or y equals, or something like that. The 0 of -3, when we write that as a factor, is x plus 3. Officially, it's x minus -3, yes, but we know it is x plus 3. The 0 as 4 is x minus 4. Okay, follow the same setup with 2 minus I. I'm going to write this out the long way the first time, in that this is going to be x minus the quantity 2 minus I. Okay, so I set it up as beginners. I don't care that we did it last year. You're still all beginners because there's been a year lapse of knowledge here, okay? Or a year lapse of just working with it. I put that as in parentheses because it's x minus that whole quantity. I'll clean it up next row. We also have to have x minus the quantity 2 plus I. So it's x minus the quantity 2 plus I. Now, could you skip what I just wrote and go ahead and jump to the next step? By all means, you can. And I'm going to write it out here as I have x plus 3, x minus 4. If I take out those inside parentheses, this one becomes x minus 2 plus I. You got it. And the next one becomes x minus 2 minus I. Now, you get the feel for it. By all means, jump to that step if you feel comfortable doing that. But be careful because that's where mistakes happen, right? Now, the directions, so lovingly said, standard form. What's that mean? We got to multiply it all out. Now, here's the recommendation I will remind you of. Life is going to be 100% easier if you multiply your conjugates together. Because when we multiply those conjugates together, all of our i's are going to magically disappear. Yep, pretty much. It's magic, okay? Now, while we're multiplying those two, what else could I do? Can we multiply the two real ones while we're at it? Sure. And then we'll multiply together. So, okay, I'm going to FOIL x squared minus 4x plus 3x minus 12. No, I didn't go ahead and clean up. You can, but I know I'm going to have to clean up this other one big time. So I know I'm going to have a cleanup step. So, okay. Now this next one, I'm going to distribute x. X squared minus 2x minus ix. Are we okay with that? That was me distributing x to the other parenthesis. Now I'm going to distribute the negative 2. Negative 2 times x. Negative 2x. Negative 2 times negative 2 is 4. Negative 2 times negative I is going to become plus 2i. Now I'm going to distribute my I. I times x. Ix. I times negative 2. Negative 2i. I times negative I is what? Minus I squared. Don't forget the squared. It makes a difference. Okay. The first parenthesis, if you didn't already clean it up, x squared minus x minus 12. You don't need me for that, right? Not at pre-cal level, I hope. The next parenthesis. Okay, what magic stuff is happening? Minus ix cancels with plus ix. Plus 2i cancels with minus 2i.
Negative 2x. Negative 2x is negative 4x.
We're going to have some like terms. Before I do that,
Negative r
I still have an I.
Doesn't it turn into like negative 1?
Yeah.
1.
Just one.
Okay, so the rule you need to remember is that, so officially, what do I want to say? The square root of negative 1 is I, right? And so then, I should have written that the other way. That's going to bug me. Sorry. I is the square root of negative 1. I squared is just negative 1. That's what you need to remember, yes? So this becomes minus negative 1, which really just becomes plus 1, right? Okay. So now, let's see. We have x squared. Brody mentioned that negative 2x and negative 2x is going to be negative 4x, and 4 plus 1 is 5. Did all of my eyes magically disappear? Yes, and here's my hint. If your eyes didn't magically disappear, go back and check for a mistake. don't just force them to magically disappear if they didn't actually magically disappear, because you could have a bigger mistake going on. Okay? Now guess what?
FOIL again.
Yep. FOIL again. X squared. I'm going to distribute it times x squared. X to the fourth minus 4x cubed plus 5x squared. Then I'm going to distribute my negative x. Negative x times x squared, so minus x cubed. Negative x times negative 4x is plus 4x squared and minus 5x. Now I'm going to distribute my negative 12. Negative 12x squared plus 48x minus 60. By the way, did I warn you to write small? I didn't. I know I didn't. Sorry. There's a lot to fill in here. Notice, mine takes my whole space when you look at my notes, so. Okay, we're there, yes? What do I see? I see x to the fourth minus 4x cubed minus x cubed is minus 5x cubed. 5x squared and 4x squared is 9x squared minus 12x squared is minus 3x squared minus 5x plus 48x plus 43x minus 60. And it matches my answer key, even better. Hey, you guys laugh, but I got to make sure I didn't make a mistake that you guys didn't call me out on. Okay. This is familiar. We did this last year, okay? Okay, let's work our way through example 3. And we're going to try and be quick about this, so I'm going to keep it moving. Example 3 asks us to write a polynomial function of minimum degree. They're not cluing us in on how many zeros to expect. Standard form with real coefficients whose zeros include 1, 1 plus 2i, and 1 minus i. What do we know? Okay, they gave us 1 plus 2i, so I also have to include 1 minus 2i.
They gave us 1 minus i, which we need a 1 plus i.
Yep.
They also gave us an x equals 1.
Do I need a conjugate for 1?
Nope.
No, it's real. 1 is 1. It's a loner here. Okay? So, yeah, fun stuff. Okay? Let's write it out. These were my conjugates. Okay? Now, it wouldn't surprise me if I go off my paper here. I'm just saying. You know, mine, yeah. There's a lot to do here. Okay, so 1 is going to be x minus 1. Now, I am going to put my conjugates next to each other. That's important. You don't want to try and multiply the 1 plus 2i and the 1 minus i. No. Put your conjugates together. So I'm going to have x minus the quantity, 1 plus 2i. And then next to it, I'm going to have x minus the quantity, 1 minus 2i. Then I'm going to have x minus the quantity 1 minus I. And next to that, x minus the quantity 1 plus I. Now, again, could you skip writing that step I just wrote if you feel confident? You can. If not, write it out. Okay. X minus 1 is x minus 1. I'm going to write these without the inside parentheses, so x minus 1 minus 2i, x minus 1 plus 2i, x minus 1 plus I, and x minus 1 minus I. Okay. Can you guys guess how I'm going to multiply these? Conjugates, which means x minus 1 is just hanging out. My recommendation, carry down that x minus 1 so we don't forget it. Okay? It's so easy to overlook. But then work with your conjugates. You just can't forget about x minus 1 at the end. So, okay, I'm going to distribute my first x. X squared minus x plus 2ix is how I write that one. Distribute negative 1 minus 1x plus 1 minus 2i. Distribute negative 2i minus 2ix plus 2i minus 4i squared. Okay. Now, you can clean that up if you want, but I'm going to multiply this next one out also because I don't want to forget about it. Okay. So now, in my other one, I'm going to start with my distributing. So now in the x minus 1 plus I times x minus 1 minus I. I'm going to start by distributing x. X squared minus 1x minus ix. Distribute negative 1 minus 1x plus 1 plus 1i. Distribute I. No, distribute I. First thing it's going to. Ix minus 1i minus I squared. Okay. I'm going to keep us moving. X minus 1 carries down. Okay, let's check out some fun stuff before I can consolidate this next one. 2ix cancels with minus 2ix. Minus 2i cancels with plus 2i. Minus 4i squared becomes minus 4 times negative 1, which is plus 4. So this parenthesis should clean up to be a trinomial. We've got x squared minus x, and minus x is going to be minus 2x, plus 1 and plus 4 is plus 5. And some fun cleanup on this other one. Minus ix cancels with plus ix. Plus I and minus I cancel. Minus I squared. Minus negative 1, which is plus 1. So now I have x squared. Feel repetitive. Minus x and minus x is minus 2x. Plus 1 plus 1 plus 2. Okay. Now, at this point, it's pick your poison. I don't know how else to describe it. We have 3 things left to multiply. I know my personal, I saved the x minus 1 for last, just because it's going to be the easiest piece to distribute. An x and a minus 1 is easy to distribute. So, me personally, I'm going to do the 3 by 3, and I'm going to get 9 terms out of it. They're going to have to condense. Okay? You do you. You can meet me in the end if you want. I don't care. So now, what am I going to do with x minus 1 in the meantime?
Keep it there.
Keep it there. Copy it down, or you're going to forget about it. Or you run the risk, at least. So now, I'm distributing x squared. X to the 4th minus 2x cubed plus 2x squared. Now I'm distributing negative 2x. Negative 2x to the third plus 4x squared minus 4x. Now I'm distributing 5. 5x squared minus 10x plus 10. Okay? Do not distribute yet. Clean up. Don't ever distribute till you've done a cleanup step, okay? Because you're just making that much more work for yourself. So my x minus 1, I carried down again. Okay, I don't know about this one. X to the fourth. Negative 2x cubed and negative 2x cubed is negative 4x cubed. 2x squared plus 4x squared plus 5x squared. 11x squared. Negative 4x minus 10x minus 14x plus 10. And need room for 2 more rows of work. A distributing row and a cleanup row. Or if you look at my actual answer key, my distributing row is along the bottom, my cleanup is squeezed in at the right because I ran out of room. So I don't know where you're at on room, but okay, distributing the x. Distributing the x means each exponent just goes up 1. X to the fifth minus 4x to the fourth plus 11x to the third minus 14x squared plus 10x. Now I'm distributing the negative 1. All my signs just flip. Minus x to the fourth plus 4x cubed minus 11x squared plus 14x minus 10. Okay, well, x to the fifth minus 4x cubed and minus 4x to the fourth, and minus x to the fourth is minus 5x to the fourth. 11x cubed and 4x cubed is 15x cubed. Minus 14x squared and minus 11x squared. Minus 25x squared. 10x and 14x. 24x and minus 10. And it matches my answer.
Let's go.
I would hope with 5 of us in this room that we wouldn't let any mistakes slip by, but
It'd be our luck.
it happens.
What happened?
Yeah. That's why in these I always like, okay, I don't want to leave a wrong answer up here. Because I don't want someone trying to use this in their homework and be like, I don't understand what we did there.
Something looks wrong.
Yeah. Okay, guys. You're going to see some of these in homework. Okay? They're big, they're bad. They're not technically difficult. Tedious. Time consuming. Tedious. Okay. Backside. Okay. Example 4. Find all zeros of this given function and write f of x in its linear factorization. Okay. We also did this last year. Okay. I taught this just the other day in Algebra 2 as well. So, all zeros. Define all in this category for me, or in this problem. Real and imaginary. How many?
5.
In this problem, there are going to be 5 because the highest degree is a fifth. It doesn't mean they're all real. It just means 5 exist. Now, I just realized I have 5x squared is on your notes, right?
Yeah.
Okay. I'm just making sure because it's handwritten in mine as a typo, but that would be called, I didn't feel like redoing the answer key once I realized the typo, so. Okay. You guys have that. Okay, guys, all zeros. All they give us is an equation. Officially, we need to start with our PRRs. Potential rational roots, or possible rational roots. Now, did we do this on, when did we do this? Have we done this year?
Yeah,
Yes,
we just did it.
Last lesson. Yes, it was on the quiz, wasn't it?
Yeah.
Okay. Sorry. My classes, when I'm teaching something in Algebra 2 and Pre-Calc, is so hard for me to keep straight who's done what when. And you guys run the unfortunate of, wait, have you seen that? I don't remember. So, okay, so we're going to start by finding our PRRs. It's not horrible in terms of space.
No, it's about.
I mean, I have space to spare on this, so, I mean, I'm keeping my PRRs up top, up close. I'm not going to give them a ton of space, but this is, I have space to spare in my box. It's the next problem we have a problem with. So, but you have the bottom of the notes you can run into. Okay, PRRs. Remind me, factors of 8 because it is the constant over factors of
Yeah, you're right.
1 because it is the lead coefficient. What are factors of 8?
Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8.
Okay, 1 and 8, 2 and 4, throw in the plus or minuses. Factors of 1? 1 times 1, plus or minus 1. Now, in reality, am I grading PRRs on this problem?
No.
No. Can you tell what your PRRs are?
Yeah.
Okay, in this scenario, I'd be fine if you leave this like this. Okay, I mean, if you want, could you continue and list them as plus or minus 1, 2, 4, and 8? You can, but this isn't, I mean, yes, I expect to see this on your paper, but I'm not just grading PRRs. This is a bigger, broader problem. Okay? Now, we have 2 options. We can go through and try all 8 of these till we see what works.
Graph.
Or we can cheat and we can peek at the graph. Okay? And what am I saying? I shouldn't call it cheat, but we're going to use the graph. And here's the deal. The graph is going to get us to our final answer quicker, but the graph doesn't give us everything. Okay? So, you're going to plug this into the calculator, and you're going to tell me the graph suggests what of plus or minus 1, 2, 4, and 8?
Whoa.
And again, do I want you actually finding the zeros?
No.
No, just eyeball it.
Oh, my Zoom is still on.
Well, it suggests
-2.
and 1
And
and
4.
Makes an N. Kinda.
which makes me feel like the other 2 are going to be irrational.
Yeah, right.
Yes.
And you can always zoom out to see what, make sure everything's there. But yeah, I mean, keep in mind, my PRRs only go up as far as +8 and -8. If you're on a standard Zoom screen, you're seeing up to +10 and -10, aren't you? So we can see all the possibilities. So your graph, it appears to cross at -2, 1, and 4. Now, does that make sense?
Yeah.
Yeah, those come from my list, yes? Now, that means we're missing 2. Imaginaries occur in pairs, the plus or minus, right? So, our job is to find the imaginaries.
Synthetic division.
Yep. Okay, so this problem's not bad. It's really not. It's just a matter of remembering. So pick one of your zeros to start with. Doesn't matter which one.
-2.
Okay. Here's the deal. Doesn't matter.
No.
You can do these three in whatever order, following the right steps. You can meet me in the end. We'll be in the same spot eventually. So -2. I'm going to have 1, -3, -5, 5, -6, and 8. Don't forget to check for placeholder zeros, yes? There's none necessary there, but just a friendly little reminder. Drop my 1, -2 times 1, -2. Add,
-5.
-5. Multiply, -2 times -5.
10.
10. Add,
-5.
+5. Multiply, -2 times 5,
-10.
-10. Add,
-5.
multiply,
10.
+10.
4.
Add is 4.
-8.
Multiply, -8.
0.
Add 0. Now, before you move on, let me remind you a couple things. First of all, the remainder of 0 needs to happen. If it didn't happen, somewhere you've screwed up. Okay? There's a remainder of 0. What does this tell me right now?
That's not for you.
-2 is one of our zeros, as we believe. That also means it's going to represent a factor of x plus 2, right?
Yeah.
Okay, now, pick another 0 to try.
-1.
Okay? I'm not trying -1.
I'm gonna try
I mean 1.
Okay, I'll try 1.
How am I saying?
I don't know either, but I'm not trying -1. Now, before you start this, what's the catch?
We have to use the 1, -5, 5, -5, and 4.
Okay, we are trying to factor this down. Do not go back to the original, or if you keep going back to the original, you can't find your imaginaries at the end. Okay, so we're going to take our new row of values and use those. And I've got to speed things up because we've got to get through that last problem. 1, -5, 5, -5, 4. We don't need the 0. Drop the 1, multiply. Add, multiply. Add, multiply. Add, multiply. Oh, crap.
You put a -4 instead of a -5. You put
Yeah.
Okay.
-5.
Okay.
I looked up and you
Okay,
put an
now,
extra 3 down. I'm like,
You
what?
guys, my on crap is, why am I not getting a remainder of 0? So, you found my mistake quicker than I did. 1, -5, 5. This should be -5. That should be 4. Okay, so, this is no, gosh darn it. Okay. Redo. -5 plus 1, -4. 1 times -4
-4.
is -4.
Remainder is
4 plus -4 is 0. Whew. Okay. Now, remainder is 0. That tells me the 1 works. That tells me I have a factor of x minus 1. We have one more to try, yes?
4.
So we're going to set up synthetic division. Again, you're going to use your new row. So 4 goes in my box. 1, -4, 1, -4. Hopefully I copied better this time. Drop the 1, multiply. Add, multiply. Add, multiply. Add. Whew. Okay, I can breathe easier. Remainder of 0. 4 works, which means
X minus 4.
x minus 4. Okay.
Can you do like x squared plus 1?
Okay, so here's the deal. I've got 3 factors. I've got 3 zeros going. My remaining 2 are right here. What does 1, 0, 1 represent?
X squared plus 1.
X squared plus 1, because it was x to the 5th, and this was x to the 4th, and this was x to the 3rd. So this is x squared plus 0x plus 1. Set that equal to
0.
0. Solve. This is
equals plus minus square root of 1.
x squared equals -1.
Okay.
X equals
Plus minus square root of
And that just be like,
Plus or minus.
But we're not going to say plus or minus the square root of -1.
Can we just say I? Plus or minus.
Plus or minus I. Okay? So, the graph suggested these three. With some synthetic division to factor us down, we are at these three. Officially, it doesn't even ask me to write my answers. It asks me for a linear factorization. So, what factors did we come up with?
-2.
So I'm going to start f of x. -2 was a 0, which gave me x plus 2. 1 was a 0, which gave me x minus 1. 4 was a 0, which gave me x minus 4. I is a 0, which gives me x minus I. Negative I is a 0, which gives me x plus I. There is your linear factorization. Okay, we've got to bust a move through example 5. Okay, I can't even guarantee we're going to get it all done. Here's the deal. If I don't get it done, I'm just going to continue teaching to an empty room, and the rest of it will be there. Okay?
Can we just stay in the empty room with study hall?
Well, you can stay in here because you aid.
Okay.
And I can write a pass if you want to stay for a few minutes and let me get through it. But I'm not requiring that. Okay? I can always write pass if I have to. Example 5, similar to what we just did, but we're going to tweak it a little bit. The complex number 1 minus 2i is a 0. They just gave me one of my answers of this lovely function. Find the remaining zeros and write in linear factorization.
That's right. 1 plus 2i be the other 0.
Okay. So if 1 minus I is a 0, then we also know that 1 plus 2i is a 0. We now know 2 zeros. How many total zeros do we need, though?
4.
4. We need to find 4 zeros.
Is this where PRR is coming?
Nope. We're not even going to do PRRs because here's the deal. My other two answers are also going to be imaginary. I'll tell you that up front. Okay? We're going to use synthetic division. They told us a 0. We don't have to go to PRRs because you're not going to get anything that works. Okay? This is not going to have any x-intercepts.
How would we know if we're doing this on our own, though, that?
If they give you an imaginary 0, start with that. Okay? Because here's the thing. We're going to have 2. Nothing else. You're going to get to an equation. You can solve quadratic formula like we just solved the last one, that type of thing. Now, okay, guys, bear with me. The first one is ugly. Upfront notice. The second one is not ugly. Okay, so synthetic division. I'm going to put in my box. I'm going to use 1 minus 2i just because that's what they gave me. As you write your row of numbers out, I recommend you leave a little more space than normal in between numbers, because we're going to have some binomials underneath them. So I'm going to write out 4. What comes after 4?
17.
Nope.
How many no? 0.
0, because there's a placeholder for x cubed. Then
17.
17,
Then 14.
14,
Then 65.
then 65. Okay, drop the 4. Multiply. Okay, don't make this harder than what it is. 4 times 1 minus 2i.
4 minus 8i.
4 minus 8i, because you're just distributing, right? Then we're going to add. What do you get when you add 0?
4 minus 8i.
4 minus 8i. Okay, prepare for fun. Now what? We have to multiply. And so we are going to FOIL 1 minus 2i and 4 minus 8i. So FOIL 4 minus 8i minus 8i plus 16i squared, which is
4 minus 16i plus 16i squared. Or
Okay.
plus 16 minus 16.
Minus 16.
Be 20. So
4 minus 16 becomes
20 minus.
Whoa, whoa, whoa. 4 minus 16. Why is it minus 16?
Because
It's a plus 16i squared. That becomes minus 16. 4 minus 16 is
Negative 12.
minus
16i.
16i. Okay, so where does that go? Under 17. Now we add. 17 adds to the
Negative 12.
negative 12. 17 plus negative 12 is 5 minus 16i. Now we FOIL. So now I'm FOILing 1 minus 2i times 5 minus 16i. 5 minus 16i minus 10i plus 32i squared. 5 goes with
minus 32.
32i squared is minus 32. So 5 minus 32
Negative 27.
minus 16i minus 10i.
Minus 26i.
Yep. Where does this go?
Above, below the 14.
So negative 27 minus 26i under the 14. Now we add.
Minus 13.
14 minus 27,
Negative 13.
negative 13 minus 26i. Guys, this is going to work. We're going to FOIL one more time. It's our last FOIL. 1 minus 2i times negative 13 minus 26i. Negative 13 minus 26i plus 26i plus 52i squared.
We assume this all cancels out to be negative 65.
Yeah, no. Minus 26i plus 26i will cancel. Negative 32 minus 52 is
Negative 65.
negative 65, which goes under where?
65.
Under the 65. And 65 plus negative 65 is
0.
0. I told you it would work.
So now we gotta use.
You had to have faith.
Can I ask?
Now, this next one looks uglier to begin with, but it actually works out much easier.
What's the nat? So what are we doing with the nasty I?
We're going to do synthetic division again.
Oh.
Because we're factoring it down. What goes in my next box?
1 plus 2.
1 plus 2i. What do I always say? You don't go back to the original, you go to your new row. It looks ugly, but because it's ugly, it works nicer. Give it a chance. You have to trust me. So 4 minus 8i,
Would it just be?
5 minus 16i, negative 13 minus 26i. You have to do this step. You can't skip it. Okay? Drop the 4.
4 minus 8i.
No. What is 4
4
times
plus
1
8i.
plus 2i?
4 plus.
4 plus 8i.
Would that just cancel the, or would it just be like 8?
Add 4 plus 4 is
8.
8. Negative 8i plus 8i. That part cancels. Okay, now 8 times 1 plus 2i.
8 plus 16i.
8 plus 16i. Oh, hey, guess what happens?
That
The i's cancel. 5 plus 8 is
13.
13.
Let me guess this.
1 plus 2i times 13.
13 plus 26i.
13 plus 26i. Shocker, it worked. And was it not nicer? It was much nicer. You guys have to learn to trust me on this.
Sure.
I try and not lead you astray. Now, guys, that was a bell. You have every right to leave. That's fine. This video will be here. Okay, if you want to stick with me for a moment, that's fine, because I will lead you through it and write a pass if I need to.
This should be 4x squared plus 8x plus 13.
4x squared plus 8x plus 13. We're going to take this factor and set it equal to
0.
0. How am I going to solve this?
Can you factor?
Nope.
Not factor. I don't know.
Quadratic formula. Here we go.
Actually,
Yep.
you're kidding me.
Never.
I'll eat.
Oh, thank you. I can't remember.
There you go. Alexa, Siri, Google, they all know quadratic formulas, so. Negative b,
Negative 8.
negative 8, plus or minus the square root of b squared, 8 squared, minus 4 times a times c, all over 2a. Clean up, negative 8, plus or minus 64 minus whatever 4 times 13 is, which it looks like I have written down that that's 208 in my notes. 64 minus 208 is negative 144 all over 8. Am I okay?
It's just cancel.
Nope.
Okay, never mind.
And why do the 8s, this is a good teaching point, why do the 8s not cancel?
Because it has another thing attached.
Yeah, this, you have to be able to cancel this denominator 8 with both numerators, both pieces in the numerator. Right now, I don't know about this square root of negative 144. So, negative 8 plus or minus. What is the square root of negative 144? 12i. All over 8. Now let's talk about Brody's constant. This denominator of 8 goes with
Negative 8.
both pieces, right? What is negative 8 over 8?
Negative 1.
Negative 1 plus or minus. What is 12i over 8?
Well, no. 3 over 2. 3i over 2. Plus or minus 3i over 2.
I'm going to say plus or minus 3 halves I. You could say 3i over 2. What is this right here?
2 different answers.
Those are my other 2 remaining zeros. Okay, so this right here, your remaining zeros. Do we have 4 zeros now? The one they gave me, the one we knew, which I guess we should say 1 plus 2i. Now, do you have another moment for me? The linear factorization. Couple key points I need to quickly make a point of. First of all, I haven't stated this. What did this problem have an a value?
Yeah.
A is always the lead coefficient. If your lead coefficient is anything other than 1, it carries down to your linear factorization. Okay? So, that 4 goes in your linear factors. Now, linear factors. X, let's start with what they gave me. 1 minus 2i. That's going to be x minus the quantity, 1 minus 2i, but can I go ahead and skip and say it's going to be x,
Minus 1 plus 2i.
you got it, minus 1 plus 2i. The other one, let's go to 1 plus 2i. It's x minus the quantity, 1 plus 2i, which becomes x
Minus 1 minus 2i.
minus 1 minus 2i. Now we've got to do these two fun boys. Fun guys? Whatever. Okay, now, x. I'm going to go with the negative 1 plus 3 halves I first, if you will. Okay? So x minus the quantity of negative 1 plus 3 halves. So that's going to become x
Plus 1 minus 3 over 2.
minus 3 halves I. Now I'm going to do negative 1 minus 3 halves I. That's going to be x.
Plus 1 plus 3 halves i.
You're catching on. Now, I like that as an answer. The book goes one step farther. Last thing.
Oh my goodness.
I know, here's the deal. The book doesn't like there being fractions here.
Well, good.
Now, by coincidence, we have this 4 out front. 4 can break into 2 times 2, yes?
Yeah.
If I take 1, 2 and multiply it into that parenthesis, and if I take the other 2 and multiply it into that parenthesis, what's going to happen with my fractions? They're going to go away. Okay, because this 4 doesn't multiply into everything. It just multiplies once. So I'm going to use it in the form of 2 and 2. So, final answer. F of x equals, my 4 is gone out front. x minus 1 plus 2i, x minus 1 minus 2i. This parenthesis, multiply the whole parenthesis by 2, yes? 2x plus 2 minus 3i. Are we okay with that?
Yeah.
And, last bit, multiply by 2, 2x plus 2 plus 3i. In all reality, I'd probably take either or, but there you go. Okay. Guys, thank you so much for sticking around. I will write you passes.
Would it matter come test time which way we're
Are you gonna be picky about that one?
We'll talk about it come review time. Okay.